This is Augustus 5 and 6 with Home Invasion version 2.0 attacking network-controlled hardware by Daniel Crowley, David Bryan, and Jennifer Savage.
Hi, everybody. So we're going to be talking about smart home technologies. And for those not familiar with the term, it's basically just sort of a blanket term describing technologies that hook up sort of non-traditional stuff in your home to a network. So things like door locks, lights, garage doors, window blinds, things like that. So whereas Home Invasion 1.0 would be some guy busting in your window and unlocking your door and stealing your stuff, Home Invasion version 2.0 is, remote. It's not physical. Or maybe there is a physical aspect, but we'll get more into that as the talk progresses. So first we want to talk about who we are and why you should listen to us as opposed to some guy off the street who's selling water bottles. So my name is Daniel Crowley, and I'm a managing consultant with the Spider Labs team at TrustWave.
I'm Jennifer Savage. I work at Tabbed Out. I'm a software engineer and security person there. We make a mobile app that lets you pay your bar tab with your cell phone.
I'm David Bryan, senior security consultant for TrustWave, Spider Labs. I do pen testing and all sorts of fun stuff for a living.
So why are we here? What are we doing here? What's the point of us being up on stage? Well, like I said, we're talking about the smart home. And so there's a couple different types of science fiction, but one of my favorite is the dystopian science fiction. And dystopian science fiction refers to a type of science fiction that is about how technology can go wrong, either technology that exists or technology that has yet to exist. And one thing about science fiction is that science fiction almost always precedes science fact. Nearly all of you have a cell phone in your pocket right now, and that was preceded by the Star Trek communicators. And so the guy who invented the cell phone actually cited that as part of the reason that he came up with the idea of the cell phone. So science fiction often precedes science fact. Sometimes the warnings provided by science fiction, dystopian science fiction, are well heeded, and sometimes they're not. And unfortunately, in this case, it seems like people aren't paying attention to the warnings here. We took a look at a bunch of different devices, not all of the devices on the market because there are a lot of them and there's a lot of ground to cover, but we just took a sampling of them and we found flaws in nearly everything we took a look at. But some of the notable things that we didn't take, that we won't be covering in this talk, there's an Android-powered oven out there. There are smart TVs, and there are actually talks that cover those that I think already happened. And then IP security cameras, things like that. So there's a bunch of different stuff out there that we didn't talk about, so this is just a sampling. So yeah, we tried to just pick things that would be in different rooms in a modern smart home.
So a few of the things that are out there now are locks, thermostats. There's even a fridge. There's a toilet, lights, and toys. But in the future, there will be entire smart cities. They're working on one now. It's called Songdo. It's in South Korea. Cisco is building it, the networking for it. It's being built from the ground up to be a smart city. You'll be able to walk up to a window, press a button, and call your kids at home. It'll be a playground for hackers. So I want to talk today about a toy that was in my daughter's room for some number of months. I found this thing on ThinkGeek, and I thought it was really cute, and it would be extremely useful. It has a video camera, a microphone, so you can check on your kids. It has speakers, it plays music, it can wake you up in the morning. It has an RFID chip, and they sell little accessory bunny rabbits that have RFID chips in them that you can hold up to the RFID reader on the bunny, and it'll respond. It also has ears that move and an LED in its belly button. Eventually, I realized I should probably evaluate the security of this toy that was in my daughter's room. And what I found was that there was, so first of all, I knew this at the time that I downloaded the Wi-Fi setup script, but there was exposure of my Wi-Fi network credentials unencrypted to the Carrot servers in order to download the Wi-Fi setup script. You have to go to their website, enter in your SSID and password, and then it generates the setup script and downloads it. In order to communicate with the Carrot servers, it uses completely plain text API calls, no SSL whatsoever, so they can be eavesdropped on. The setup package download also happens unencrypted. The code is signed, but there's a way around the signing using a technique I call Python module hijacking, and I'll go over that in a moment. So here we have an example of eavesdropping on one of the API calls. You can see here that this is getting the webcam action. So webcam action equals video. And then after that, you see a token. That token is one-time use. It's from start till you send a stop packet. And then every time you want to connect and use the API again, you have to talk to the Carrot servers and get a new token. However, if you are eavesdropping on the communication, because it doesn't happen over SSL, you can just steal the token and access the video feed in your web browser. Where's the, okay. All right, so I'll show you a video of that in a moment. So here's the Python module hijacking explanation. So Python module hijacking, it works very similar to LD preload or DLL hijacking. So essentially in Python, you have something called the Python path, and it's a list of directories that Python will look for the modules in order to load them. So if you have a module that you're using in your Python script, it will first look in the current directory of the script that is being run, and then it'll look in a series of other directories listed in the Python path. Most languages have fixed this bug. A lot of languages were doing this. For instance, with DLL hijacking, actually, the Windows operating system was doing this. Their fix was to move the current working directory to the end of the path, of the search path. So anyway, all you have to do to perform a Python module hijacking attack is create a Python script that's the name of the module, place it in the same directory as the script in question, and when the script executes, it will execute your module instead of the intended one. Now, the Carrot's autorun Wi-Fi script has a reference to simple JSON in the imports. And so you just create in the case of the Carrots, you create a simple JSON.py file in the same directory as the autorun Wi-Fi script. And at the time that somebody sets up their Carrots, it will run that instead, and you'll get code execution on the device. And since you download the autorun Wi-Fi script over an unencrypted connection, you can man in the middle of the connection and replace their download with yours. So it's a kind of remote code execution if you can get it at the time of download of the setup script. And like I said, the code for that was signed, but the signing doesn't check for the libraries, so it defeats their code signing. So just to recap, an attacker could man in the middle the insecure connection to the Carrot server, replace the user's download with the malicious version, use a vulnerability to make the Carrots run their own code, and get a bunny botnet. Additionally, for the home user that has a Carrots right now, if you're good with coding, you can sort of do a bunny break and have it run your own code instead using this vulnerability. Carrots app for the iPhone, the Carrots controller app, and I'm going to move the Carrots' ears using the app. This will send a request via the Carrots API to the Carrots server, and then the ears respond by moving. Now I'm happen to be eavesdropping on that request over here, and if I look at the request itself, I can grab from it an authentication token. It's a one-time use token, but what I found is that I can reuse this actually and use it to capture video instead. So I'm going to grab the interactive ID and the one-time use token, copy it, go over here to my web browser, paste it in, and change the action. So here it says the action is the ear moving. We're going to change the action to webcam. And let's see, it needs to be webcam action equals video. Hit enter. And now, on the machine that I'm using to eavesdrop on the carrots, I get a handy dandy webcam feed. Hi guys! So this is eavesdropping on the Carrots' Toys webcam. All right.
So next up, we're going to talk about a product from Belkin in the Wemo product line. The Wemo product line is a series of smart home products. There's this product, which is basically a box you plug into an electrical outlet, plug something into that the Wemo switch, and then you can turn whatever you've plugged into it on and off over the network or over the internet if you set up remote access. So we took a look at this. There are other products in the line. There's a baby monitor. There's a motion sensor. We didn't take a look at those. We just took a look at this particular device. And so first off, this has this is controlled via UPnP through an iPhone app that you download and use this to set the thing up, connect it to your Wi-Fi network, and then issue it the commands to turn on and off from your phone. But the version of libUPnP in use is vulnerable. So it's a remote pre-auth vuln that gets you root. So you can root this thing and then have a point of persistence within someone's network that a forensics investigator, for instance, would probably not look to as the source of attacks in a breach scenario. So, but if all you want to do is to turn this thing on and off, rooting it would be doing it the hard way. Because what you can actually do is just use UPnP to turn this on and off. The thing about the UPnP protocol, while it's well known as far as automatic network configuration for embedded devices and software and things like that, it's actually a generic remote procedure call protocol. So in this case, it's being used to trigger the whatever's connected to it to turn on or off. So that's using the set binary state action. So you can turn it on and off from the network, local network, no authentication. You can also change the name of it. So if you have multiple Wemo switches in your house, each of them will bear a name that you've given it. So if I have access to your home network, I could switch around the names so that you think you're turning on and off one device and you're really toggling the state of another. I can also push new firmware over UPnP. And while the firmware is signed, there's a potential for pushing an old firmware where the libUPnP vuln is still open. So that's interesting. So Belkin addressed, as I alluded to just a moment ago, Belkin addressed the vulnerable version of libUPnP, and they did not add authentication to the UPnP interface. But what they did is put a little notification in the iPhone app that just says, if you're using this on a network with people you don't trust, be aware that they can turn whatever you have connected to this on and off. So at least they're letting people know about it. But here's a quick demo on that. So we're going to talk about the Belkin Wemo. I'm going to show you how to turn this on and off from your computer. So the Wemo is an electrical outlet that you can control over the network. The protocol involved is called UPnP. So Nmap has a nice NSE script called broadcast UPnP info, which tells us all the hosts within multicast range that will respond to UPnP queries. So it gives us the descriptor XML file for each one. So I'm going to take that and feed that to a tool here. By the way, this tool that I'm using right now is a custom script, which I will release after the talk. So it goes through and enumerates all the devices, services, and actions, and organizes them into
various directories. So we want the basic event service, because that has things that we want, like set binary state, which turns the Wemo on and off. So we're going to cat set binary state, and this gives us the post request that the UPnP request generator has made, and we're going to give that to burp repeater so that we can make that request. And I need to change this to either a 1 or a 0. You see it's Boolean here. And we can see by the fact that there's no illumination.
All right, so the demo gods must really hate me. Originally, I was planning a live demo of this, but that little box just died on me about 2 hours ago. And now the video cuts short. So needless to say, the demo gods hate me, but you're just going to have to trust me that you can turn this on and off from the network. So next we're going to talk about the Sonos Bridge.
So the Sonos is a sound system you can purchase at places like Target, and this is the bridge for it, which is the little device that all of the speakers connect to wirelessly, and that the controller software connects to. You can run this controller software on your laptop or your cell phone. Anything that you have your music collection on, you install the controller software onto, and then feed the music to the Sonos Bridge, and it goes out to your speakers. The problem with the Sonos is that it has a web server on it, and whenever a controller connects to it, there's a ridiculous amount of information disclosure about the controller. So your laptop, information about your laptop is exposed in the web interface without authentication on the bridge. And so just to give you an idea, here's a list of all of my network shares, their permissions, the UUID and the group IDs. Here's a netstat output, again, available without authentication. Here's a process list from my laptop. Here is the current date, time, and a list of users on the machine. Here is ifconfig and who am I. So, I mean, there's no legitimate reason that this sound system needs this information about my machine, and there's absolutely no legitimate reason that it needs to be exposed without authentication to everybody that's on the same network. It's ridiculous.
So we hacked a toilet. Indirectly, mind you, it's a $6,000 toilet that we would have to get shipped from Japan. So we didn't order this toilet, but it does it's controlled via Bluetooth through an Android application that anybody can download. So we took a look at it, we audited it, and what we found, among other things, like this wonderful image.
Which is part of the app.
This is actually taken from the app. I understand why it's a poo. I can understand why it has arms and legs because it's from Japan. I don't understand the police hat. Some sort of policeman. I don't know. But there are a bunch of images like this, different. Anyway, I don't want to get too much into it, but it was weird, and I just had to include this in the slides. But what we found, besides these images of policemen, was a default, a hard-coded Bluetooth pin. There is no place to put in a username and password when working with the application. But there was some Bluetooth routines that paired with the Satis toilet using a hard-coded pin of 0000. There's no buttons on the interface that we could find in the user manual to initiate a Bluetooth pairing. So there's a couple of buttons that control various features, So what can you do with this application? Well, you can play music on the toilet. You can open and shut the lid. You can control the flushing mechanism. And it also has a bidet, which you can control from the Android application. So just imagine for a moment that you're sitting on doing your business, and the toilet starts screaming and spraying water at you from underneath. That's a pretty bad day, and obviously this isn't as bad as some other things that we're going to be talking about. But it was we couldn't leave this out of the slides. So the next thing we're going to go ahead.
Oh yeah. So next we'll talk about the Insteon Hub. The Insteon Hub is basically a home automation gateway. Does everybody know what a home automation gateway is? A few of you guys. All right, so home automation gateways basically sit on your network and will allow you to talk to your devices, such as lights, garage doors, alarm systems, motion detectors, etc., etc., and act as a bridge between your internet or your network and your home automation devices. The one that I tested was the Insteon Hub, and what actually happened was they released this product last year, and I ordered one in December of 2012, got it, installed it, configured it, got it set up, and then I went, all right, I'm a security person, I should probably make sure that this is a decently secure component or app, right? Downloaded the app, installed the app, configured it via my Wi-Fi, my home Wi-Fi, turned off the Wi-Fi, ran TCP dump on my firewall, and then initiated a connection. What I saw really disturbed me. First and foremost, there was no encryption, right? So anybody who was in between my connection could see that traffic going across the internet, or if I'm in a coffee shop or wherever I might be. Second thing, there was no authentication or authorization to run commands to turn on and off lights. That disturbed me. We had a reporter that we were talking with last week from Forbes that published an image on her article. And this is the image from that article. This is someone's house where they've named their house with their last name. And you can basically go in and essentially control all of their lights, whatever it might be. And the reason you could find that, or one of the things that I discovered was there's a time zone setting in these devices through this web interface. And this web interface is open to anybody on the internet. It's also open to anybody to run API commands against that. But the web interface allows you to set a time zone so that you can configure sunrise and sunset, so your devices will go on at sunset or off at sunrise, those kinds of things. But within that, you can actually tell it what city you're in, right? So if you can tell it what city you're in, and someone names it maybe by their street address or their last name, there's a pretty good chance that you're going to be able to look up where this device is located. Besides the fact that a lot of IP addresses are geocoded or geolocated, right? So, when we're talking about an attacker attacking someone's home, this should be pretty simple to find where they live, and maybe even gain access or gain control of their garage door opener, a door lock, etc. Really it's, controlling all the things or all the Internet of Things. So the one thing I will mention is they did do a product replacement, or what I would call a recall. Basically, I got a call from them in March saying, hey, we want to replace your device. I went, what? Oh, but I'm going to give a talk on this device. I can't replace this device. And they insisted that I replace it, and I said, all right, fine. Still haven't returned the old one, but I got a new one, right? So the new one, I sat down, plugged it in, and started working on it. There's still a lack of TLS SSL, so all the connectivity is unencrypted. However, they're using basic HTTP auth, which is super secure, right? Because base 64 is not encryption. Remember that. So one thing I discovered is they're using hard-coded tokens. Once you set up this device, it actually does have authentication on it, which is good. However, the password that they're using for the hard-coded authentication is the Insteon ID, which is also the last 3 octets of the MAC address. So if you're on the same network, you can totally break into any one of these guys. Or if you have enough time, you can start throwing 16 million combinations at these. Oh, and there's no back off, right? So that means that anybody can run a script hitting the web server as many times as they want for as long as they want, and it's never going to stop responding. So I call that a security fail.
And remember that this hub connects, or has the potential to connect to things like door locks and garage doors and alarm systems and carbon monoxide detectors and water sensors and fire sensors, just like all sorts of things that are a big risk if they, a big problem if they get compromised. Another device much like this that we're going to talk about is the Mi Casa Verde Verilight. So quick funny story about this. This is by far the most broken product in the entire talk, I would say. It's pretty bad. And my colleague just came in for DEF CON just today, and he was telling me that on the taxi ride to the con, the guy started asking him the standard security questions like, is X website safe? How easy is it to hack someone's email? What's the best antivirus? And then, he said, oh, by the way, I have a home automation business that I'm running on the side. And my colleague's like, oh, really? Yeah, it's like, yeah, I'm curious. I don't know if you would know this at all, but I was wondering how secure home automation systems are. And he's like, well, my colleague Dan Crowley, he's talking about him at this con, and which one are you talking about? And the guy looks at him and says, oh, the Mi Casa Verde Verilight. And he just had to keep himself from laughing, because he already knew, I showed him a preview version of this talk. And so let's dive in. So here's what's going on with this. So first of all, the web console has no authentication by default. So that's mistake number one. If you do want to set up authentication on it, you can enable that. But it has some problems. So let's talk about the separation of privileges for a moment. So there's an information-only user, a guest user, and an admin user. Information-only means you can see the status of devices. Guest means you can turn the devices on and off. And admin means you have full control of the unit and can change settings, save settings, etc. So there are three ways that I found, and there's probably more, but these are three that I found to bypass that. Actually, the path traversal is another way, so there's four. So first of all, you can update the firmware as a guest. So, and it's just the firmware is not signed. It's in a squashfs package, so you can, with freely available tools, take apart the firmware, add a backdoor, something like that, and then put it back together, upload the firmware to the device as a guest. So you can get root that way. There is a settings backup where you can download an unencrypted archive of various settings files on the device. This includes etc password, which in the version of Linux that's running on the Verilight contains password hashes. So you can crack the root password and then use the SSH interface on the device to log in as root. This one's my personal favorite, test Lua code. So as a guest, you can run just any Lua code you want on the device. So it's like code execution as a feature. And the best part is it runs as root. And you can drop to a shell. So you can just do os.execute, whatever shell command you want, and it'll run as root. And it's amazing. So there's also a path traversal flaw. So as a guest user or higher, you can pull any file you want off of the Verilight. And the web server runs as root, of course, so you can pull any file you want, including etc password, crack the hashes, use SSH to get in. So there's a cross-site request forgery flaw as well, which you can use to execute several of these attacks. So again, this uses UPnP, and there's just no authentication on UPnP. And what this device actually exposes via UPnP is a control interface for all the devices hooked up to it, which again can include things like door locks. And we actually have a door lock here that we're going to unlock from the podium real quick. So there's no authentication on the UPnP daemon. And the best part about that is that the run Lua, there's an action on there called run Lua, which does the same thing as the code execution as a feature. So and it runs as root. So even if you have the web interface password protected, even if there weren't the issues that there were with the web interface, there's still a way to just run code as root as an unauthenticated user. as long as you're on the same network. Now, the thing about UPnP is it is rife with potential for cross-protocol exploitation, because it's basically just HTTP. And the other thing is there's no standard port for the control messages sent with UPnP. So what you can do is craft a web page to do a CSRF-style attack against the Virolite and just add some sort of backdoor as root. Just tell the system to grab a interpreter payload and run it, something like that. So you don't even necessarily have to be on somebody's home network to execute some of these attacks. On top of all that, the version of libupnp that they're using is vulnerable to the same attack that we talked about with the Belkin-Wemo switch. Now, departing from all the remote code execution stuff, there's a server-side request forgery bug. And this is a bit odd to put at the end of all this stuff, but you'll see why this is relevant in a moment. There's a script called proxy.sh on the Virolite, where basically you give it a URL, it fetches the contents of that URL and returns the contents to you. So you essentially, it's a proxy. It is exactly what it advertises. Now, let's talk for a bit about the remote access architecture on the Virolite. The Virolite remote access architecture works with a broker server, so you can traverse NAT. So each Virolite unit connects via SSH to the forwarding servers and forwards a port back from the forwarding server to the web interface on the Vero. Now what this means is anybody who can bypass the firewall in place on the forwarding servers can access and control every single installed Virolite unit connected to the internet, which is mostly what people are doing. So this doesn't require, it doesn't necessarily require a compromise of the forwarding server, although that would work. You could just find some way to bypass the firewall. You could find some way to compromise the firewall. You could find a way to compromise a server that isn't, that's on the same network segment, so you're not firewalled. There's a whole bunch of things. But what's concerning and what might be a problem is that there is a script on each forwarding server called proxy.sh.php, which takes a URL as a parameter, fetches it, and gives it to you. It gives the response to you. Now, I can't test, because of the CFAA, I can't test that this has the same exact flaw, but when it's named the same thing, plus a .php, takes the exact same arguments in the exact same format and appears to do the exact same thing, there's a good chance that this is just copied and pasted code, and that the same vulnerability that exists on the Virolite exists on the forwarding servers, which means you can ask the forwarding servers, if this is actually the case, you can ask the forwarding servers to request a page from themselves on a particular port, a high port, which is likely to be used by a forwarded port to a Virolite. So, like I said, we can't test this because we haven't received authorization from the manufacturer, but it is concerning. So just to recap, 3 methods of authentication bypass, 7 different methods to get root. 2 of these attacks being remotely exploitable using social engineering techniques, and a potential for every Virolite to be compromisable with a very, it's just like a glass of water on the edge of a table. Just all it takes is just something small. So it's a really bad scene. And now we'd like to do some demonstrations for you with some of the products that we talked about. So first we're going to do a demonstration with the carrot. So Jen, maybe you can explain what's going on.
Explain what's going on. Go ahead and go open the mic. I'll hold this.
So can you move away from the LED with your fingers? Thank you. So I have preloaded the malicious code, the lol.mp3 file onto the USB drive that presumably was something that you downloaded at the time of downloading the setup script. And right now it's loading up the Carrots OS, and it's checking out the fact that there's a USB drive in the bunny spot.
To the internet.
Right now it thinks it's trying to connect to the internet. It thinks it's trying to run the auto-run Wi-Fi script. And instead it's going to run my MP3 file because that's what I told the script to do. But you could potentially have it take pictures on a regular basis, send them back to your server, you know, all sorts of things that are very bad.
Do you want to go? Or actually, no, I'll go.
Okay.
Yeah. All right. So next we have the Insteon demo. So remember how I said there's no authentication, no authorization, all that fun stuff. What do we have to do to zoom in on this guy? What do we have to do to zoom?
Control and scroll.
All right. So here's the GET request that we have to send it. Basically embedded in this GET request, I think it's this guy right here. That's the device ID that I'm basically telling the Insteon, hey, turn this device on, right? This message right here is the on code, right? And so I should be able to say, well, it's on already, right? So if oh no!
Did it really?
Yeah, no.
Okay. That's all right. I think we're doing...
Fail.
Burp sweet.
I think we're doing okay on time, so we should be able to set it back up.
All right.
Let me just relaunch Burp real quick.
We're going to do a little dance while we wait for the Burp Suite to start up again.
So last night, the Carrots went out last night and had a bit of a rough time at its party and came home with a DEF CON tattoo. I don't know if you guys noticed. I might have to have a talking to with it.
So which one? Is it 100?
I think it's 100.
100, okay.
Isn't it? Yeah, because...
Okay. So let's...
Yeah, grab one of them. All right, so now we can turn the sucker off. Yay! No authentication. Okay. Let's go ahead and turn it back on again here. Just so that we can have a little light. All right, so that's the Insteon. Yeah, go ahead.
So the next thing we're going to do, they say that if you put a gun on the table in Act 1, you must fire the gun by Act 3. Here we have a door lock, and I've mentioned door lock several times. So what I'm going to do is to unlock this door lock from my computer. Once I get everything set back.
Yeah, so basically he's got to go back. He's got the PHP script that he's written, a custom code that will go through and enumerate the UPnP components. Once he basically enumerates those components, pulls all the UPnP areas down, he can then go and grab those, throw them into Burp Suite, and then basically use the repeater function. I mean, we could do this with Telnet if we wanted to, but it would take us a long time to manipulate it, so we just use Burp Suite to make it quicker, faster for us. And essentially what it, ideally, if it works, it should open the door lock, right?
I believe this is at 101 right now.
I think it's 101, yeah. And port 80 or whatever.
So, so this is what the UPnP request looks like. It's just a SOAP request. So you have just the control URL, the action in the SOAP action header here. So this is toggle state for the door lock. So that means if it's locked, it unlocks it and vice versa. And so it takes no argument, so I should just be able to hit go here. And the lock unlocks. Woohoo! Thank you.
Wait.
So this is useful within a particular time window. But can I get a volunteer from the audience, please? Just raise a hand if you're willing to volunteer. Okay, you with the camera. I'd like you to just give me a 4-digit number. Any 4-digit number. 5389. 5389. So
okay.
we'll try that on this lock. 5389. No dice, but we have a solution for that. So there is also an action available for this device which adds a pin to the door lock. Yeah, I know, it's incredible. So we need door lock, set pin. So this takes a couple arguments. The first one is JSON, which I have no idea what the JSON is for, to be perfectly transparent. But if you just put an empty JSON string, it doesn't seem to mind. User code name, again, it doesn't seem to mind if you put, I think it's just a descriptive thing for the web interface. So I'm going to put black hat briefings 2013. And for the pin, 5389. We hit go, thing says okay. It communicates with the door lock. And now, 5389. And I believe that's all we have for you today.
So basically the conclusions are that we've got all these devices, right? This Internet of Things. They're all connected together, and people are using them, right? People are using them in their homes. There's a really good chance that mom and pop are going to start using them, and people don't really understand the security that they really don't have around these devices, right? I think it's really important to go back to the manufacturers and say, what are you doing? You're deploying products without authentication or authorization. Now, this goes back to, if you think about it in terms of breaking in, if someone breaks into your house forcibly with a brick, with a hammer, with a lockpick, those are ways that you can identify that someone's broken into your house, right? You have forced entry. There's a chance you can go to the insurance company and get money for that. If someone breaks into your house and there's no signs of forced entry, how are you going to get your insurance money back, right? Those are the questions that we really have to ask ourselves. Is this technology really worth it? I think, from a perspective of controlling lights and things like that, yes. From the perspective of controlling door locks, it's way too immature to be able to trust. So, all right. I think that's what we have. So thank you very much.
So at this point, I'd like to open up for questions, if anybody has questions.
Make sure you badge out and give us a survey if you're leaving. Questions?
You.
I'm sorry, can you... Yeah, so it exposes the city based on the fact that there's a time zone, right? So that's the unauthenticated version, essentially.
There's no chance it communicates the SSID of a Wi-Fi.
No, so the Insteon hub does not have any Wi-Fi component to it all. It's just Ethernet based. What it has is a 900 megahertz Insteon bridge, essentially, so that it can talk to the Insteon devices over 915 megahertz. But no Wi-Fi component in it at all. What I did say with the MAC address, right? The MAC address, if you're on the same network, you could identify the new authentication just by knowing the MAC address. Does that make sense? Yeah. Okay. Go ahead.
I just want to make a statement. I'm Bryan from Falcon. I'm the director of AppSec. So you mentioned the firmware URL that we allow that to be sent.
Yeah.
It actually has other authentication and encryption methods, so you can't just send any firmware URL. It won't actually be updated.
Yeah, and it's limited to official Belkin firmwares. I'm sorry, I should have made it more clear that I have not tried to downgrade the firmware.
So we do appreciate your work, but we work really hard to make sure we secure the products and our constant.
Yeah, and we didn't even have to talk to you guys about these. These were fixed before we could even start to reach out to you guys. So thank you.
Yeah, you guys were real good.
Another question?
What's your opinion on the latest wave of Bluetooth Low Energy smart devices? There's been a lot of Kickstarter projects where you go and leave your phone in front of your front door and it has some sort of device in the back that I guess flips the lock, or you can lock replacement, but basically it was a Bluetooth.
So Bluetooth is a lot harder. I mean, I haven't done a lot of research on the Bluetooth Low Energy, but I know that the prior versions of Bluetooth were a lot more difficult to brute force, but it's not impossible, right? I mean, I don't know if you have anything to add to that.
Not having touched them myself, I can only really speculate, but I can say that all of this has made me very uncomfortable about hooking things that could potentially be dangerous if compromised up to networks, even personal area networks. Clearly you're not hooking it up to the internet, so there's like a whole range of threat actors that aren't involved here. But I just don't feel good about hooking door locks up to networks. If it's the difference between putting a physical key in or putting a phone up to it, I would rather just use a key.
I'm a little more ballsy. I would probably use it if I tested it and couldn't find a bug.
Go ahead.
For people like me that are scripting dummies, is there a good way to enumerate
UPnP?
So there are several tools that will help enumerate UPnP devices. The one that I used is an Nmap script, which it's called broadcast-upnp-info. There's also one that's a unicast version in case you're scanning over the internet and just hoping that it will actually respond over the internet, which it's not supposed to. But broadcast UPnP info and UPnP info. There's also, I believe it's a Windows tool called Intel Universal Control Point. There is a Python script called Miranda, which does the discovery and the description phase and also allows you to do some control stuff. It's a little bit buggy. I notice it crashes on me a lot, and you also can't issue control requests without doing the discovery first. So if you're going across the internet, Miranda is entirely useless to you, which is part of why I wrote my script. But those are a couple UPnP tools that you can use. Also, Metasploit has a UPnP discovery module. And that one, I think, will actually check to see if the version of libupnp is vulnerable or not. Sure. Go ahead.
Did you mention you be releasing your custom script for download?
I will be. It will be on the GitHub, the Spider Labs GitHub.
Is that all the money?
You can buy them on ThinkGeek if you want. I no longer use the bunny. We leave it unplugged. My daughter loves the bunny, so we leave it in her room unplugged. But, I would no longer use it. The vendor simply did not respond to the disclosure. I think that was a different version of it, but yeah.
The Carrots is essentially the successor to the Namaz tag.
Yep.
Do you have a question, or you just got your hand up? Oh, never mind. I'm seeing things.
I mean, so there's a lot of privacy concerns, with these devices. Some of them do upload their data to the cloud. For obvious reasons, we're unable to test any of the servers on belonging to these companies, so we don't know if they're secure. Even if you get one of these devices and you can test it yourself and you feel reasonably secure about it, if it's connected to somebody else's server and controllable through their server, then if their server gets owned, that's a problem. So these are all things that I think the security community needs to be proactive about consumer advocacy and doing this testing ourselves.
Question out there. So the question, if I heard this right, do we find any potentially dangerous items such as taps? Like water taps?
The home automation gateways can be hooked up to HVAC systems, and David made a good point the other day about he lives in Minnesota, in Minneapolis.
It gets cold.
It gets very cold, and so if you were to shut off somebody's heat in the middle of the winter, it could burst the pipes. So there is some potential for it, but it's maybe a bit of a doomsday scenario.
I mean, the other thing is, in doing some of the reconnaissance, you would see people that would have hot tubs or, heating elements or something hooked up to their smart home, right? And, that could cause either a house fire or potentially, right, or a really high electric bill. So.
I don't think we want to go in the direction of FUD, right? So we talked about things that we tested. Let's leave it at that.
Yeah, we didn't manage to cause any fires within the course of our testing.
It's a question.
Yeah.
I was just going to say, I can tell you for heaters, they actually are allowed to be turned off remote. You can actually control them in the house because regulations are whether they manufacture actually do it or not, they're supposed to.
Right.
They're not supposed to do that connection on something else.
Right.
Well, so the internet-enabled thermostats you can turn on and off or auto. I don't know if they have a setting that says if they go below 50 degrees that they will turn on again, especially if they're in the off mode.
I've got a Nest thermostat, and I've done some preliminary audits on it, and it seems pretty secure, but it does indeed have a low override setting. Like where if it gets lower than 10 degrees Celsius, I don't know if that is in Fahrenheit, but it'll automatically turn on regardless of what the setting is if it is that temperature.
That's good to know. Now, an attacker could come along and say, no, override, right? I mean, I've done SCADA system audits where, I've been talking to a guy, I'm like, hey, can you get to your stuff? And he's like, no, I can't get to it. But that's all right because the system goes into auto mode unless you have admin override turned on. So a lot of these things will potentially still have some sort of admin override code. And that may still exist inside of a consumer thermostat. But, I guess...
We didn't test the Nest at all.
Confirm that.
Right.
So
you also have to think about the possibility of what happens when the device fails. Potentially, and I think that's a possibility. Yeah. We actually wanted to test the Nest learning thermostat, but we weren't able to get a hold of one in time. There was just so much stuff out there. So.
All right. Any other questions? Thank you very much.
Thank you.